Okay, so again, 3-4 is called solving exponential and log equations. Obviously, these are different from what we've done before. Either they have an equal sign and we haven't had it before, or it jumps up a little bit in level of difficulty. So the first thing, and we've done this as already, is the one-to-one property. Okay, but just as a reminder, the one-to-one property is used when you can set the base on either side of your equal sign and an exponential to be the same base. So if I had 2 on the left side, I had 16 on the right side, I'd rewrite 16 as a power of 2, and then once the bases are the same, I set the exponents equal to each other. We did these with simpler, like just raising the power. Now you're going to get equations in the top, okay? So I'll rewrite the equation so that they have the same base, I'll set the exponents equal to each other, and then solve for the variable. When we get to natural logs, or solving exponential equations, you're going to see that you'll have an exponential that cannot be changed to the same base on either side of the equal sign. So it might be that you get just exponential on one side that you can't change to be the one on the right-hand side, or 2 that you can't change them. And so what you're going to do with these is you're going to isolate the exponential expression. So the part that has the exponent, you're going to get on the side by itself. And then just like multiplication is to division, and addition is to subtraction, natural log is to exponential. So if I have an exponential I can't change base on, then I take the natural log on either side of my equal sign. Once I get to that part, I can bump the exponent to the front of my log using the properties of logs, and then solve for the variable. So we're actually going to make ln a verb. We're going to ln both sides of the equation if you get an exponential that you can't change the base on. So they'll look something like this. So A says solve for x. A, so you can kind of think about it, would be something that would be on the non-calculator portion. I would look at both bases and I would see if I could make one the power of the other. So what do I know is both a power of 64 and 32? 2. So I'm going to break this down. If you don't see it, then I'm going to do 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. How many 2s is that? 1, 2, 3, 4, 5, 6. So this is 2 to the 6th raised to the 3x equals 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2, or 1 less than the 64. 1, 2, 3, 4, 5, 2 to the 5th raised to the 2 plus x. Now when I raise a power to a power, I multiply. So I'm going to multiply these out and these. I get 2 to the 18x equals 2 to the 5 gets distributed to both, 10 plus 5x. As soon as I get to the point that the bases are the same, I'm going to ignore the bases and look just at my exponents, where 18x equals 10 plus 5x, and solve. So I'm going to subtract 5x from both sides. And then divide by 13. So changing the base so it is the same. If I've got an exponential on either side of the equation, or either side of the equal sign, changing the base so it's the same. And then once the base is the same, setting your exponents equal to each other. Questions on that one? Okay, B. I only have one exponential, right? E to the x. On the right-hand side, I've got 4. Is there a way to rewrite 4 so that its base is e? No, this is when we ln both sides of the equation. So we're going to say ln of e to the x and ln of 4. Rewritten, that looks like this. Now, ln can be rewritten as what? Log base e. If I did that, I get log base e of e to the x. What happens on the left-hand side? Cancels out, leaving me with just my exponent. So you don't need to rewrite it, but if you can't see it from the beginning, remember ln of e, you just cancel, take the exponent, and it would equal ln of 4. So if this was on the non-calculator portion, you would leave it like it is, as ln of 4. If it's on the calculator portion, then obviously you're going to find ln of 4, which is 1.386. So you would want to know how to do it both ways, because you could have that on the calculator portion or the non-calculator portion. Questions on that one? Okay, so now look at C. Again, just one exponential and it's E. So I'm going to have to ln both sides, but before I do that, I have to do what? I got to get the 9 on the other side. I got to get the exponential on the side by itself. So I'm going to add the 9. I get e to the x equals 28. And then I'm going to ln both sides of my equation. ln of e cancels. I just get x equals ln of 28. And again, if it's on the non-calculator portion, I leave it like that. If it's on the calculator portion, ln of 28 is 3.332. And if it's on the calculator portion, these are easy to check, right? Because I can actually take this and I can plug it into here, and using my calculator, I can find e to the x of 3.332, and my answer minus 9 is 18.994. Now, it's not exact, because why? And we rounded it, right? We rounded this number, which means it should be close, but it doesn't necessarily mean it's going to be exact. Questions so far? Okay, D looks like this. Left side is 5 to the 2x. Right side is 1 over 125. Can I change the base so they're the same? Yes. So if I bring 25 to the top, it becomes 125 to the negative 1. And what power of 5 is 125? 3. So this becomes 5 to the 2x equals 5 to the negative 3. My bases are the same, so I can ignore them and set my exponents equal to each other. And I get x equals negative 3/2, or negative 1.5. Easy to check. Plug it back in with or without the calculator. You should be able to do that one. Good so far? Questions? Anybody still copying it down? Okay, then we get to log functions. So you're going to see a couple of different types of equations with logs. Remember that one of the things you can do is rewrite a log. So if a log is on one side of my equation, I can rewrite it as exponential by using the base, coming over, picking up the number on the other side, and then dropping off, leaving what's there. So if it's only one log on one side of the equation, I'm going to convert it into exponential and solve the way we were just doing it. The biggest thing with logs is you must check these answers, because if I get a number that is negative or 0, once I plug it back in, whatever's here cannot be negative or 0. So you might, and a lot of times it's with a quadratic, you'll get 2 answers and one will work and one won't. You have to check your log equations. Exponentials, you can have a negative exponent, you can have a 0. But logs, you cannot. So when you get your answer for logs, you're going to plug it back in and not really work all the way through unless you need to. Just check to make sure if when you plug it back in, it gives you a 0 or a negative on the big part of the log. So not the base, but the big part of the log is where you'll be plugging it into. So they look like this. Solve the log equation algebraically. Approximate the result to 3 decimal places. And sometimes you'll need to and sometimes you won't have. So like this one you don't need a calculator for. What is log? What's the base? 10. So I'm going to say that 10 to the second power equals 5x. What's 10 to the second power? 100 equals 5x. Divide both sides by 5. And x is what? 20, right? That I didn't need a calculator for. So if this kind of question's on my test, it's not going to be on the part that has a calculator. If you take this number and plug it back in, it can serve two purposes. One is actually check your answer. So log base 10 of 5 to the 20 would be log base 10 of 100, and 10 to the second power is 100, so I know my answer's right. That would be an optional thing to check. The important part is making sure that you can take this and plug it back in and not get a 0 or a negative in that spot. If it's a 0 or a negative, I rule the answer out. In this case, it would be no solution. You cannot find the log of a negative number, and you cannot find the log of 0. B, what would you do first? Move to 5, the 5 to the other side. So subtract the 5, 2 ln of x equals 9. Then what?
Make the 2 an exponent.
So you can do this two ways. I can make the 2 an exponent, so it'd be ln of x to the second equals 9, but then I'm kind of stuck, right? You'll see, I can keep working. I can change that to log base e of x squared equals 9. The e can come over, pick up the 9, and then I have to do plus and minus the square root of e to the 9. So it works, it's just trickier.
Mm-hmm.
From the beginning, what else could you have done?
Divide by 2.
Divide both sides by 2. ln of x equals 9 over 2. You could keep it that way. You could make it 4.5.
Is it only the positive e to the 3?
Because when you plug it back in a check, you'll eliminate the negative.
Yeah.
Yep. So then I get log base e of x equals 4.5. And then e is going to come over and pick up the 4.5. And then with a calculator, you would find e to the 4.5. And I get 90.017. Now, if I had continued this way, I don't know if you heard me, but if you continue this way and you find plus and minus the square root of 9, you're going to get plus and minus of e to the 9, 90.017. And then you're going to see that this is a log. You're going to try to check to make sure that when you plug that in, it's not negative, which means you'd rule out the negative and just keep the positive. Questions on that one? So remember, ln you're going to treat as log base e if it's on one side of the equation. Okay, example 3, solve the equation algebraically, round to 3 decimal places. So what am I going to do first with a?
7 over.
Subtract the 7. Negative 2 to the ex equals negative 2. Then what? Divide by negative 2. E to the x equals 1. What do you see there? X has to be 0. If you don't see it, then I have to ln both sides of the equation. I get ln of e to the x equals ln of 1. This cancels. X equals ln of 1. Log base e of 1 would be 0. So this kind of question would be when you don't have a calculator. Now I can plug this back in to check, but I'm not checking it as though it's a log where I'm going to rule it out. I would just check to make sure it had the right answer. Okay, so it doesn't have a log in my initial question, so I don't have to check it the way that I check the other ones. This would just be to check to see if it's right, not to rule out a root. Questions on that one? Okay, B, e to the 2x minus e to the x minus 12 equals 0. What do you normally do when you have like two variables, like an x to the second and an x? You have to factor it, right? I can't combine those into one term. It's not like they're both logs that I can condense. So I'm going to factor it. This is going to be e to the x and e to the x because those times each other would be e to the 2x. And then I've got to find the factors of negative 12 that sum to a negative 1, which would be what?
3 and 4.
Positive 3, negative 4. Now, if either of those parentheses equals 0, then my entire thing is 0, so I'm going to split it and solve it, and I get e to the x equals negative 3, and e to the x equals 4. And then I'm going to ln both sides of my equation. ln negative 3 equals ln e to the x. ln e to the x equals ln of 4. What's wrong with ln of negative 3? Cannot have a negative in ln, right? Can't find the log or the ln of a negative number. So that one gets canceled. And then this one's going to be x equals ln of 4, which without a calculator would stay like that. With a calculator, you would do ln of 4. So if you had a calculator and you went to do ln of negative 3, it will yell at you. That's the good news. But if you don't, you've got to know you cannot find ln of a negative number. So this would be the answer without a calculator. This would be the answer with. Questions on those? All right, you do A. And then we'll work through B. So you do A, solve it algebraically, and round it to 3 decimal places. You're going to need your calculator for that one. And then we'll do B. All right, so for A, I'm going to rewrite ln as what? Log base E. So this is log base E of x equals negative 3. The E is going to come over and pick up that negative 3. E to the negative 3 equals x, which is 0.0497, which rounds to 0.50. And again, with a calculator, that would take 5 seconds to check. Just find that ln of 0.05 and see what you get. So be careful with those because those should be easy. All right, now we get to B. So this is the first one in which we've had more than one log on either side of the equal sign, right? What do we do to condense down those logs? Because it's addition, it's going to become multiplication, right? So I need to condense it so that there's only one log on either side of the equal sign. And to do that, because it's addition, it becomes multiplication. Now, if there is one log on either side of the equal sign and they're the same base, it's just like having the same base on either side of the equal sign. So I can literally ignore my logs and I can set what's next to them equal to each other. So x times x minus 2 equals x plus 4. Left-hand side, I'm going to distribute x squared minus 2x equals x plus 4. And then as soon as you see the squared and the non-squared, you should get yourself a heads up. You're going to have to factor. So I'm going to move everything to one side. I'm going to subtract the x and the 4. I get x squared minus 3x minus 4 equals 0. And then I'm going to factor this x minus 4, x plus 1. Set them each equal to 0. And I get x equals 4 and x equals negative 1.
What if you were to like subtract it and then divide by x plus 4?
What do you mean subtract?
Like subtract the log 3x plus 4 to like the other side?
You can. It would just then be equal to 0.
Okay.
You'd still have to condense it into 1.
Yeah.
But then you can, so you would get 3 to the 0, because now you've got one log, right?
Yeah.
You'd get 3 to the 0, which is 1, equals everything on the left-hand side, and then you'd have to solve it that way. So I'll work through that way in a second. But yeah, it works. Okay, so now I've got my two answers, which are negative 1 and 4. Remember I said that if there's logs in the original equations, you have to check them. It's not like check them to see if they're right. You have to check them because you could rule out a root. So if I plug in negative 1 here, I cannot find the log of a negative number. If it happens even just once, it gets canceled out. So if it worked here but didn't work here, it would be no. If it worked in those two places but didn't work on the other side, it'd still be no. And then the 4, if I plug it in here, it's fine. 4 minus 2 is 2. That I can find. 4 plus 4 is 8. That I can find, which means my answer is just x equals 4. So what Danielle was just asking is, can I move, you said move the log base 3 x minus 4 to the other side, right? So you did this. Log base 3 of x plus log base 3 of x minus 2 minus log base 3 of x plus 4 equals 0. Then I can condense them all into 1. So I'd get log base 3 of x times x minus 2 over x plus 4, because subtraction means division, equals 0, log base 3. Then 3 comes over, picks up the 0. 3 to the 0 equals x squared minus 2x over x plus 4. I get 3 to the 0, which is 1, equals x squared minus 2x over x plus 4. And then I'd multiply both sides by my denominator. And I'm on the same step I was as we were here, right? So it still works. Yep. But again, you've got to check it. Make sure anything that starts with a log, you're checking those answers. Questions on that one? All right. So this is basically all of it wrapped up in one slide. These are the different, because honestly, the hardest part of this section is figuring out what to do at the beginning, okay? If you can change the base to be the same on both sides of your equal sign, you're going to change the base and set the exponents equal to each other. So that would be like a 2 to the x equals 2 to the 3. Same base on the bottom, set the exponents equal to each other. If you can solve for e, then you're going to ln both sides of the equation. So this is if you end up with something like e to the x equals 10. If I can get e on the side by itself, there's only one e, and I can get it on the side by itself, then I'm going to ln both sides of my equation. If there's only one log, so it says something like log of 3x equals 4, then I'm going to put the equation into exponential form by taking the base, coming over, picking up the other side, dropping it off, and then solving it. If there's one ln, I'm going to convert it to log base e and then put it in exponential form. So let's say it was ln of 3 to the x equals 4. I'm going to rewrite that as log base e of 3x equals 4, and then convert it to exponential, and then solve it. And the last is if there's multiple logs, if it's log of something plus log of something equals a number, or log of something minus log of something equals, even if it's another log, I'm going to condense the ones on one side into one log, and then either convert to exponential if it's got equal to a number, or use my one-to-one property if it's like the one on the bottom. And all three of these you must check. So if your original equation has a log or an ln, you have to check your answer. You don't have to go all the way through and check to make sure it completely works. You just have to make sure that you wouldn't be trying to find the log of 0 or the log of a negative number.